everyone, good morning. My name is Jera Patricia Bivar and we are going to discuss this topic about modern astronomy. Throughout human history, scientists have struggled to understand what they see in the night sky. Famous astronomers, many of them are great scientists who mastered many fields, explain the heavens with varying degrees of accuracy. Over, over the centuries, a geocentric view of the universe, with Earth at the center of everything, gave way to the proper understanding we have today of an expanding universe in which our galaxy is but one of millions. And these lists are some of the most famous scientists from the early days of astronomy through the modern era and summary of some of their achievements. After 14 centuries since Ptolemy V, noted scientists noted important discoveries that gave rise to the birth of modern astronomy. These were Nicolaus Copernicus, Tycho Brahe. Tycho Brahe was a Danish astronomer and nobleman who made accurate observations of the movement of celestial body in an observatory built for him by King Frederick II of Denmark in 1576. He was able to invent different astronomical instruments with the help of his assistants and made an extensive study of the solar system. He was able to determine the position of 777 fixed star accurately, or 777 fixed star accurately. Johannes Kepler, when King Frederick II died and the successor did not fully support Brahe's work, he moved to Prague in 1599, where he was supported by Emperor Rudolf II and worked as an imperial mathematician. Emperor Rudolf II recommended Johannes Kepler to work for him as an assistant. Kepler was born to poor German family and studied as a scholar at the University of Tübingen in 1589. Brahe and Kepler worked. Brahe and Kepler had an unsteady working relationship. Kepler was Brahe's assistant. However, Brahe mistrusted Kepler with his astronomical data in fear of being showered by his assistant. Brahe assigned to Kepler the interpretation of his observation of Mars, whose movement did not match Brahe's calculation. Kepler was tasked to figure out what Mars followed as it revolved around the Sun. Many scientists that Brahe gave this task to Kepler to keep him occupied and left Brahe to develop his law of planetary motion. Kepler discoveries from Brahe's data. Kepler postulated that there must be a force from the Sun that moved the planets. He was able to conclude that this force would explain the orbits of Mars and the Earth, including all the other planets, move fastest when it nearest from the Sun and moves slowest when it farthest from the Sun. Eventually, Brahe decided to give all his data to Kepler, hoping that he would be able to prove his tectonic system and put together new tables of astronomical data. This table was known as Rudolphine tables, new after the Roman emperor, and was useful in determining the position of the planets for the past 1,000 years and the future 1,000 years. This this table was the most accurate table that is known to the astronomical world. And this is our Kepler laws of planetary motion. When Kepler tried to figure out Mars' orbit, it did not fit the then famous theory that a planet follows a circular path. He then excuse me. He then postulated that instead of a circular path, planets follow an oval or an ellipse orbit. This orbit matches calculations and explain the irregularities in the movement of Mars. He was able to formulate his first law of planetary motion, the law of ellipse, which describes the equal path followed by the planets, was elliptical, not circular, with the sun at one focus of the ellipse. So you can see Kepler first law, sun and planet focus. And second law, the law of equal areas. The second law, which is the law of equal areas, states that when an imaginary line is drawn from the center of the sun to the center of a planet, the line will sweep out an equal area of space in equal time intervals. The law describes how fast a planet moves in its orbit. A planet moves fastest when it is nearest the sun and slowest when it is the farthest from the sun. And still, the same area is swept out by the line in equal amounts of the time. So, third law, the law of harmonies. The law of harmonies, which is the third law, describes that the square of a planet's orbital period T2 is proportional to the cube of a planet's average distance from the sun, R3. It states that the ratio of the square of the period of two planets is equal to the ratio of the cube of the average distances of these two planets from the sun, or where the subscript 1 indicates planets 1 and subscript 2 indicates planet 2. So you can figure so that's all, guys. Thank you for watching this video. I hope you have learned this topic, and thank you. Bye.